Hello, and welcome to the Weldment Design Buyer's Guide. Welded structures can be found throughout a wide variety of products, including automation equipment, industrial machinery, scientific equipment, and many other specialized fields. If you design welded structures and components, then you need a design tool that will help you complete these often complex design challenges fast and with the minimum amount of effort. Everything from basic structure design through to final documentation are all essential parts of the design process. SolidWorks is unique in this area. It goes much deeper than the basics and ensures that any design challenge is covered. To showcase these design tools, we will create a frame for this bag-in-box machine from Avco Automation, from start to finish. To start the design from scratch, you need a way to quickly lay out the frame in three-dimensional space. SolidWorks makes this extremely easy to do, with tools that guide you through the process, and with continuous cursor feedback. You will see this regularly as we continue. Since design changes happen often during development, adding intelligence to the design ensures that changes can be made quickly and without any fuss. SolidWorks gives us powerful control over even the simplest of geometry. Notice how adding dimensions to our box drives the overall size. In this way, we can rough in the shape and then precisely refine the size afterwards. SolidWorks keeps the basic design tasks simple, allowing you more time to focus on the complex design challenges that are critical to the success of your project. As we wrap up the layout of our frame, the next step is to add the structural elements. This is where you need the most flexibility from your CAD tool. In SolidWorks, this is simple. All we need to do is specify the standard, the type, and the size. There are unlimited possibilities here, as SolidWorks provides thousands of sizes from the downloadable Content Center. And you can even create your own unique profiles as well. In this case, we'll stick with a basic square tube. As we add more structural elements to our design, intersections are going to have to be met with accordingly. SolidWorks has many choices here as well, including butt joints, overlaps, weld gaps, miters, and more. We'll go with a simple butt joint for our case. Adding as many elements as you need, all in one operation, saves a lot of time and hassles. Just ensure that you have full control over individual corner treatments as well. This ensures you end up with precisely the design you want, not what the software dictates is possible. This is important because you want to focus on getting the design right, not how to use the design tool. Now that we have the basic shape and overall size of our frame completed, let's add a few other elements to look a little deeper at features critical for weldment design. In this case, a guard around the perimeter. This is a slightly smaller size tube than what we used before, and in this case, we don't want to locate the tube based on its center. SolidWorks does not limit you to specific locations on a profile. We can position or locate a tube any way that we want, ensuring proper alignment based on design criteria. In this case, we created the guard tubes after the overall frame was completed, so we'll need to do some trimming. SolidWorks provides an extremely simple solution for this. All we need to do is choose what tubes we want to trim and what tubes to trim with. Simple. We can do this anywhere on our frame, and the tubes are separated into individual pieces automatically. We can even choose which segments to keep or discard. In this way, we can easily open up the front of the machine frame. It's this level of flexibility which makes all the difference. Now that we have all of these tubes in place, we want to ensure the frame looks good, and for sanitary reasons is watertight. So we'll add some end caps. Again, SolidWorks provides a wide variety of choices for us. Things like thickness, flush-mounted, even control over chamfered corners. And they're all quick and easy to do. Once we're satisfied with our end cap, we'll want to add it to the end of each open tube on the frame. Like before, we can do this entire operation from one command. There's no need to repetitively specify our end cap style. Simply choose each location and an end cap is placed. And because we're doing this in 3D as well, it's simple to navigate by just rotating and zooming in on the appropriate areas. Now we want to talk about the real challenge: designing the frame around an actual machine. Most frames don't exist by themselves, but are part of a much larger system. We're going to take a look at how SOLIDWORKS can work in the context of an assembly. To make things a little easier to see, we'll filter out most of the machine, except for a few of the components we want to reference. SOLIDWORKS makes working at the assembly level of a design easy. The exact same tools we have seen already are available here as well. There are no special modes or environments, so the way you create and modify designs is consistent, whatever task you're working on. In this case, we want to create a mounting plate for a pneumatic slide assembly. We will also need to add some tubing to connect the mounting plate to the main frame. This is the bread and butter of designing in SOLIDWORKS: referencing components in their actual locations in the final design and connecting the dots. You don't have to use any measuring tools or special workarounds to make sure all of your components are lined up and connected to each other. To ensure these components bolt together, we're going to use SOLIDWORKS' powerful Hole Wizard. This tool is the all-in-one solution for fastened connections, providing a variety of hole types, such as counterbored, countersunk, drilled, tapped, and many others. If you've ever had issues with misaligned holes during assembly on the shop floor, you'll love that SOLIDWORKS allows you to easily reference other components here as well. In this case, we simply add a center point to the center of each slot on the adjacent component. Automatic alignment made simple. Gussets are an easy way to strengthen structural designs, and these should be just as easy to create and modify in your design tool. Like all of the other tools we've seen so far in SOLIDWORKS, all the options are there to get you just what you need. These basics include overall size, location, chamfered corners, and thickness, just to name a few of the many options available for creating gussets. Let's add one final design element to our frame: a mount for an overhead gantry system. Here we will see again how easy it is to create our geometry right on the components that we will be mounting to the frame. This will ensure, like before, that not only is the design fast and efficient to create, but most importantly it's accurate, as the geometry itself we've created is derived from the matching pieces in the assembly. One thing to note: if at any time any of these components were to change, the corresponding plates and tubes of our frame would update accordingly as well. This means we don't have to spend time tracking down changes in multiple locations or documents. And adding this design intelligence took no time at all. Many designs are symmetric or contain multiple similar components. You don't want to waste time duplicating effort or carrying out repetitive tasks. Beyond a wide variety of patterning tools, SOLIDWORKS can easily mirror these plates and tubes to the other side of our frame. There's nothing easier than the work you don't have to do. We've completed all of the major design elements to our frame, but there's one significant piece missing: the welds themselves. Like every other tool in SOLIDWORKS, we'll see that we can quickly create any type of weld we could imagine, from single straight welds to a weld on both sides. We can control the offset from the ends and, of course, intermittent and staggered conditions. Once again, we find ourselves needing to do a lot of the same thing. We need to create welds at every single joint on our frame. In this case, we're going to put an all-around weld at the intersection of two tubes. So what about all of the other locations? In typical SOLIDWORKS fashion, there's a fast way to do this. Swipe selection is like a paintbrush, where all we need to do is swipe across the intersection of each joint. SOLIDWORKS automatically adds a weld to each location. This is just another example of how SOLIDWORKS gets the job done fast, so you can fully document your design without compromise. Of course, no design is complete without documentation. This should be a simple task, as all the information should be available directly from your 3D design. In SOLIDWORKS, we can just drag and drop the views we require, and everything's there. A cut list is a valuable tool for figuring out materials for order processing, and it's generated automatically, providing quantity and lengths for each tube. To make sure we know which tube goes where, we can also automatically balloon the entire view. There are choices here for balloon layout as well, allowing you to create a great-looking drawing or to simply adhere to company standards. We can even include a weld table if we need to calculate the overall weld required for the job. And dimensions? Well, they come for free too. Every dimension we created in our design can be brought right into the drawing, saving us hours of time. Selecting the right tool for your design needs is no easy task. This buyer's guide highlights many areas that are important considerations when looking for quick and efficient tools for weldment design. We hope you have found it a valuable resource. To find out more information on how SOLIDWORKS can help you overcome your weldment design challenges, please contact your nearest reseller or request more information on the SOLIDWORKS website.